In the fast-moving world of humanoid robotics, Tesla's Optimus Gen 3 has emerged as a game-changer, redefining performance standards and steadily gaining ground in one of the most competitive markets on the planet, China. As of late 2025, this advanced bipedal robot is no longer just a futuristic prototype. It is actively demonstrating superior capabilities in autonomy, dexterity, adaptability, and cost efficiency. While China remains the global leader in humanoid robot production volume and supply chain dominance, Tesla's Optimus Gen 3 has managed to outperform several of the country's most prominent models, including Fourier Intelligence's GR1, Unitree's H1, and UB Tech's Walker S2. However, how could all these humanoid robot models simultaneously surpass the superiority of the Tesla Optimus? Before we begin, please help us reach 20,000 subscribers. It would be a huge motivation for us to keep bringing you amazing episodes about Tesla humanoid robots and all the latest AI and EV innovations from Elon Musk. Tesla Optimus Gen 3, with the movements, are powered by custom in-house servo actuators that deliver smooth, energy-efficient motion. Optimus Gen 3 can walk at speeds of up to 6 miles per hour, squat, climb stairs, and maintain balance even when pushed. Battery life supports up to 8 hours of continuous operation, and the entire system is built on Tesla's vertical integration philosophy. The same neural network architecture and real-time inference hardware that power Tesla's full self-driving vehicles are used to give Optimus its exceptional environmental perception and decision-making ability. What truly sets Optimus apart is the tight integration with xAI's Grok language model. This allows the robot to understand natural language instructions, learn new tasks through observation and imitation, and continuously improve via reinforcement learning. In factory pilot programs throughout 2025, Optimus units have demonstrated the ability to perform repetitive assembly work at up to 10 times the productivity of human workers without needing breaks. Tesla has stated plans to scale production rapidly, with target pricing below $30,000 per unit in high-volume production, combined with over-the-air software updates that continually enhance performance. China's humanoid robot ecosystem, by contrast, has grown explosively thanks to strong government support, massive manufacturing capacity, and a clear national strategy to address labor shortages caused by an aging population. Companies such as Fourier Intelligence, Unitree, Robotics, and UB Tech have delivered capable and competitively priced machines that excel in specific domains. Fourier Intelligence's GR1 is a strong industrial and rehabilitation-focused humanoid. Slightly shorter and similarly lightweight, it offers impressive load-carrying capacity and stable walking. The GR1 has been deployed in warehouse and logistics settings, where it performs tasks such as pallet moving and basic material handling. However, its software stack is more conventional, relying heavily on pre-programmed sequences and occasional teleoperation for complex operations. While reliable in structured environments, it lacks the fluid, adaptive intelligence that allows Optimus to handle unexpected situations autonomously. Unitree's H1 has gained worldwide attention for its speed and agility. This tall, lightweight electric humanoid holds a record for the fastest running speed among bipedal robots. Equipped with advanced LiDAR and depth cameras, it navigates complex terrain with confidence and is marketed for applications such as logistics, inspection, and emergency response. Yet, while its locomotion is exceptional, the H1's hand dexterity is significantly more limited. Fine manipulation tasks, such as picking up small or fragile items, threading cables, or assembling electronics, remain challenging compared to what Optimus Gen 3 routinely demonstrates. UB Tech's Walker S2 has carved out a strong position in both industrial and service applications. Compact, energy-efficient, and equipped with innovative self-charging capabilities, it has been deployed in factories for material transport and in commercial settings for customer interaction and light chores. UB Tech has secured large commercial contracts and benefits enormously from China's manufacturing ecosystem, which enables fast scaling and cost advantages. Still, like most Chinese models, the Walker S2 often operates best in hybrid mode, combining onboard AI with remote human supervision, which can introduce latency and limit full autonomy in dynamic, unstructured settings. When compared directly, several advantages of Optimus Gen 3 become clear. First is the manipulation capability. The 22 degrees of freedom in each hand, combined with advanced tactile sensing and vision-based neural control, allow Optimus to perform a far wider variety of precise tasks than the more rigid grippers found on most Chinese humanoids. This difference is especially noticeable in electronics assembly, quality inspection, and household chores. Second is software intelligence and learning ability. Optimus benefits from end-to-end neural networks trained on enormous datasets, many of which originate from Tesla's vehicle fleet. This gives it an unparalleled ability to generalize, adapt, and learn new tasks with minimal additional programming. Chinese models, while improving rapidly, still tend to rely more on task-specific programming and rule-based control, which makes them less flexible outside of their designed use cases. Third is long-term cost of ownership. Tesla's projected unit price, combined with over-the-air updates, modular design, and reduced need for constant human supervision, promises significantly lower lifetime costs than many current alternatives, even those that appear cheaper up front. The arrival of Optimus Gen 3 in China has not gone unnoticed. In 2025, Tesla initiated several pilot deployments in warehouses and factories within the country, showcasing real productivity gains in labor-intensive environments. The presence of such a capable robot has intensified pressure on domestic manufacturers to accelerate their own AI and autonomy development. At the same time, it has highlighted the strategic value of combining world-class hardware with next-generation software, an area where Tesla currently holds a clear advantage. Despite China's dominance in supply chains and volume production, Optimus Gen 3 has demonstrated that superior artificial intelligence, integrated end-to-end learning, and relentless software iteration can overcome hardware scale differences, at least in the early commercial phase of humanoid robotics. As the industry moves forward, the race is no longer just about who can build the fastest walker or the strongest lifter. It is increasingly about who can create a general-purpose, learning-capable robot that continues to get better and more valuable over time. In that contest, Tesla's Optimus Gen 3 has set a new benchmark, one that the rest of the world, including China's talented robotics companies, will be striving to match and surpass in the years ahead. What's happened next? How will the Tesla Optimus eclipse all the competition? Before we begin, please help us reach 20,000 subscribers. It would be a huge motivation for us to keep bringing you amazing episodes about Tesla humanoid robots and all the latest AI and EV innovations from Elon Musk. Tesla has pushed the boundaries of what the world believes is possible in humanoid robotics. At the NeurIPS 2025 conference in San Diego during the first week of December, visitors who crowded around the glass enclosure were treated to something almost surreal. Fingers curled, twisted, waved, and pinched with the casual grace of a concert pianist warming up, the hands rotating slowly in mid-air. Tesla moved almost all actuation out of the fingers themselves and into the forearm, where 25 compact linear actuators per arm pull on steel tendons that run through low-friction sheaths. The fingers are covered in a soft silicone skin whose compliance mimics human tissue, allowing the hand to conform around irregular objects while pressure sensors embedded in the fingertips provide continuous force feedback. The result is a grip that can be both extraordinarily delicate and surprisingly strong. The same hand that cradles an egg can lift a 20-kilogram kettlebell without hesitation. Elon Musk immediately added that the version now in internal testing, internally called V3, will carry 50 actuators per hand, nearly triple the present count, pushing dexterity into what he openly calls superhuman territory. According to Musk, the V3 hand will be capable of performing microsurgery, tying surgical knots, or playing complex classical piano pieces with dynamics indistinguishable from a human performer. While the hands have rightly stolen headlines, an equally revolutionary advance has occurred below the knee. Tesla has completely redesigned the foot and ankle complex to achieve something the robotics community long considered a holy grail: true dynamic running that replicates the spring-like mechanics of human locomotion. Earlier humanoid robots, even sophisticated ones like Boston Dynamics' Atlas, relied on flat-footed shuffling or stiff-legged hopping. Optimus 5, 2.5, and especially the internal V3 prototypes, now run with a pronounced heel-to-toe rolling motion, using a compliant ankle that stores and releases energy very much like the Achilles tendon and arch of the human foot. The new foot is built around a segmented carbon fiber structure that functions as both skeleton and spring. A large posterior calf actuator drives plantar flexion, while a smaller anterior actuator handles dorsiflexion. Between them sits a tunable elastic element, essentially a high-performance synthetic tendon that recycles energy on every stride. During filming at Tesla's Palo Alto lab in late November, an Optimus was recorded sprinting across a gymnasium floor at just over 20 kilometers per hour, knees bending deeply, torso staying nearly upright, and feet slapping the ground in a cadence almost identical to a human jogger. The robot even demonstrated the ability to come to a complete stop from a sprint in 2 strides, absorbing impact through the ankles rather than locking the knees, a behavior that dramatically reduces stress on the rest of the structure. This combination of compliant ankles and energy-storing feet fundamentally changes how Optimus balances and moves. Where previous humanoids required constant small corrections from gyroscopes and wide, cautious steps, the new design allows the robot to lean forward aggressively, letting gravity do part of the work, then catching itself with each elastic footfall. The result is not only faster locomotion, but also far greater efficiency. Internal Tesla documents reportedly show the V3 lower limb consuming roughly 40% less power at a brisk walking pace than the rigid-legged Gen 2, and the gap widens dramatically during running. More importantly, the gait looks natural. Onlookers at NeurIPS repeatedly described the robot as creepy in a good way, because the motion no longer advertised its mechanical origin. The integration of these 2 breakthroughs, the 22 degree of freedom hand and the fully articulated energy recycling foot, transforms Optimus from a promising prototype into a machine that can plausibly inhabit the same physical world as humans. What do you think about this? Feel free to share your thoughts in the comments section below. We hope to bring the best information to you. Please give a thumbs up if you like this. Join Techno Creator by subscribing and hit the bell icon so you will not miss out on any awesome videos. We value your feedback. Thanks for watching. Until then, stay safe and have fun.